Hi friends, our solar system is a really cool place. It's a vast and fascinating collection of celestial bodies, each with its own unique characteristics and mysteries. From the blazing sun at the center to the icy comets on the fringes, there's so much to explore and understand. It's like a group of objects all going around a star we call the sun. The sun's immense gravity keeps everything in orbit, creating a delicate balance that has persisted for billions of years. This system is our neighborhood in space. It's where our planet, Earth, lives. Earth is just one of the many planets that make up this cosmic family, each with its own story to tell. The solar system is full of different things, each one special. From the rocky inner planets to the gas giants further out, and even the tiny dwarf planets, every object has its own unique features and history. We have planets, big and small. Mercury, the smallest, is closest to the Sun, while Jupiter, the largest, is a massive gas giant with dozens of moons. Some are made of rock like Earth and Mars, and some are giant balls of gas like Jupiter and Saturn. These gas giants have thick atmospheres and are known for their stunning rings and numerous moons. There are also dwarf planets like Pluto, which was once considered the 9th planet. And let's not forget the countless asteroids and comets that zip through space, remnants from the early solar system. Moons go around many planets, making their own mini-systems. For example, Jupiter has over 70 moons, each with its own unique features, and Saturn's moon Titan even has lakes of liquid methane. Between all these things is a lot of space. This vast emptiness is not completely void though, it's filled with the interplanetary medium, a thin soup of particles and energy. This is called the interplanetary medium. It consists of solar wind, cosmic rays, and tiny dust particles that travel through space, influencing the environment of the solar system. It's not empty though, it has tiny particles and energy that affect the planets and other objects. These particles can create beautiful phenomena like the auroras on Earth and other planets. Learning about our solar system helps us learn about our place in the universe. By studying the planets, moons, and other objects, we gain insights into the formation and evolution of our own world. It's a complicated and always changing system that is super interesting. The more we learn, the more we realize how interconnected everything is, and how much there is still to discover. In the middle of our solar system is the Sun. It's not just any star, it's the star that makes life on Earth possible. The Sun is the heart of our solar system, providing the energy that fuels everything from the smallest plants to the largest animals. It's a star, a giant ball of hot gas that gives off light and heat. The Sun's surface is a seething, boiling mass of energy, constantly churning and erupting with solar flares and sunspots. These phenomena are a result of the intense magnetic fields generated within the Sun. The Sun is incredibly big. It makes up over 99% of everything in our solar system. To put it in perspective, you could fit about 1.3 million Earths inside the Sun. Its immense size and mass give it a powerful gravitational pull. Because it's so big, the Sun has a strong pull called gravity. This gravitational force is what keeps the planets, moons, and other objects in our solar system in their orbits. Without the Sun's gravity, these celestial bodies would drift off into space. This pull keeps all the planets and other objects going around it. The Sun's gravity ensures that the planets follow their paths, creating a delicate balance that has persisted for billions of years. The Sun's energy comes from something called nuclear fusion. This process occurs in the Sun's core, where temperatures reach millions of degrees. Here, hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy in the process. This happens in its core, where tiny parts of atoms called hydrogen join to make helium, creating lots of energy. This energy then travels outward from the core, through the various layers of the Sun, until it reaches the surface and is emitted as light and heat. This energy travels through space as light and heat, reaching Earth and the other planets. The sunlight that reaches Earth is essential for life, driving photosynthesis in plants and providing warmth to sustain ecosystems. Without the Sun, our solar system wouldn't exist. The Sun's energy is the driving force behind the weather, climate, and even the water cycle on Earth. It influences everything from ocean currents to wind patterns. There would be no light, no heat, and no life. The absence of the Sun would mean a dark, frozen world where life as we know it could not survive. The Sun's presence is crucial for maintaining the delicate balance that allows life to thrive. It gives our planet energy and makes our solar system work. The Sun's energy powers everything from the smallest microorganisms to the largest ecosystems, making it the true powerhouse of our solar system. Close to the Sun are four rocky planets: Mercury, Venus, Earth, and Mars. These planets are known as the inner planets of our solar system. They are distinct from the outer gas giants and have unique characteristics that make them fascinating to study. These planets are small and heavy. Their surfaces are solid, unlike the gaseous outer planets. This solid ground is made up of various types of rocks and metals, giving them a dense and compact structure. They are mostly made of rock and metal. This composition is a result of their formation process, which involved the accumulation of heavy elements in the early solar system. Over time, these elements coalesced to form the terrestrial planets we see today. They're also called terrestrial planets, meaning Earth-like. This term highlights their similarities to our home planet, particularly in terms of their solid surfaces and geological features. Mercury is the smallest planet and closest to the Sun. Its proximity to the Sun means it experiences extreme temperatures with scorching days and freezing nights. Despite its small size, Mercury has a significant impact on our understanding of planetary formation. Venus is almost as big as Earth but has a thick atmosphere that traps heat, making it super hot. This runaway greenhouse effect makes Venus the hottest planet in our solar system, with surface temperatures hot enough to melt lead. Earth is special because it has lots of water and life. Our planet's unique position in the solar system allows it to maintain liquid water on its surface, which is essential for life as we know it. Earth's diverse ecosystems and climates make it a vibrant and dynamic world. Mars, called the Red Planet, has a thin atmosphere and signs that it might have had water long ago. The presence of ancient riverbeds and minerals that form in water suggests that Mars once had a more Earth-like environment, raising intriguing possibilities about past life on the planet. The inner planets have solid ground and are close to the Sun. Their proximity to the Sun influences their climates and geological activity, making them dynamic and ever-changing worlds. They are interesting worlds with different features and stories. Each of these rocky planets offers a unique glimpse into the history and evolution of our solar system, providing valuable insights into the processes that shaped our cosmic neighborhood. Farther out are the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets are much bigger than the rocky planets. They are mostly made of hydrogen and helium, which are gases. Jupiter is the biggest planet in our solar system. It has a huge storm called the Great Red Spot. Saturn is famous for its beautiful rings made of ice and rock. Uranus is tilted on its side, so it has crazy seasons. Neptune is known for its strong winds and blue color. The gas giants are interesting with stormy atmospheres and many moons. They are very different from Earth. Besides the 8 planets, we also have dwarf planets. These are smaller than planets but still go around the Sun. The most famous is Pluto, which was changed from a planet in 2006. Other dwarf planets are Eris, Haumea, and Makemake. Planets have cleared out their paths around the Sun, but dwarf planets share their orbits with other space rocks. Even though they're small, dwarf planets are interesting. They teach us about how our solar system began and changed. Many planets have moons. These are like mini-planets that go around bigger planets. Some planets have a few moons and some have lots. Jupiter has more than 79. Moons come in all shapes and sizes. Some are rocky, some are icy, and some even have air. Earth's moon is important to us. It controls the tides and helps Earth spin steadily. Some gas giants have rings. These rings are made of tiny pieces of ice and rock that circle the planet. Saturn's rings are the most beautiful and easy to see from Earth. The space between planets isn't empty. It's filled with gas, dust, and tiny charged particles. This is called the interplanetary medium. The Sun's energy and magnetic field control it. The solar wind, a stream of charged particles from the Sun, is a big part of this. It interacts with the planet's magnetic fields, creating things like auroras. The interplanetary medium also has dust from asteroids and comets. This dust can reflect sunlight, creating a faint glow called zodiacal light. Gravity is what makes everything in our solar system move. It's the pull between any two objects. The bigger an object, the stronger its pull. The Sun's gravity keeps the planets in their paths. It balances the planet's forward movement with the Sun's inward pull, making them go in ovals called ellipses. Gravity also affects moons, asteroids, and comets. It shapes our solar system. Humans have always loved space. We've sent many spacecraft to explore our solar system. These missions have taught us so much about our neighborhood in space. Spacecraft have visited all the planets, some dwarf planets, moons, and asteroids. They've sent back amazing pictures and information. Some famous missions are the Voyager probes, which explored the outer planets, the Hubble Space Telescope, which took amazing pictures of faraway galaxies, and the Mars rovers, which explored Mars. We will keep exploring space. Future missions will explore Mars more, study the icy moons of Jupiter and Saturn, and look for life beyond Earth. Hey everyone! Our solar system is way bigger than just the planets and moons we learn about. There's so much more out there. We're going to talk about two super cool places, the Kuiper Belt and the Oort cloud. Imagine a giant donut made of ice, way past Neptune. That's the Kuiper Belt. It's a huge area filled with icy stuff, and it starts about 30 times farther from the sun than Earth is, and goes out to about 55 times that distance. We call that distance an astronomical unit. The Kuiper Belt is home to dwarf planets like Pluto, Haumea, and Makemake. These icy bodies are made of frozen gases like methane, ammonia, and water, the same stuff you find in comets. Scientists think the Kuiper Belt is like a time capsule, holding clues about how our solar system was born. Even farther away, like a giant bubble around our solar system, is the Oort cloud. This is really far out, from 2,000 to 100,000 times farther from the sun than Earth is. The Oort cloud is also made of icy objects, and it's where those comets that take a really long time to orbit the sun come from. These comets are like messengers from the past, bringing bits of the very first stuff that made our solar system. So, the Kuiper Belt and the Oort cloud aren't just cold, icy places. They're like history books telling us about our solar system's past. By studying them, we can learn more about where we came from and how everything came to be. Thanks for watching. Don't forget to like, subscribe, and share this video with your friends.